Swinburne University of Technology.
Hi and welcome to Swinburne Codecasts. I'm Andrew Kane.
I'm Jake.
I'm Ruben.
And I'm Cliff.
And in this series we're going to look at the concepts related to procedural programming.
Each video covers one concept in depth and demonstrates to you how you can achieve certain tasks with a programming language.
And when we step through the code, we'll be visualizing the computer's memory, and that's something we call hand execution.
We'll also be providing you with an output window to show exactly what the program's going to be doing, whether it outputs to the terminal or whether we've got a graphical interface to do that.
Okay, we hope you enjoy this series and we'll look forward to seeing you soon.
Bye.
Bye.
That's pretty good.
This has been a Swinburne production. Swinburne University of Technology.
Hi, welcome to this podcast in which we're going to look at the installation of programming tools for Windows. So what do we need? Well, we're going to start by installing the Google Chrome browser, if you don't already have that. Then we need to install the MinGW development tools and a Console2 program which will allow us to interact with those tools. We'll then install the free Pascal compiler, Sublime Text with the package control and the ability to export to HTML. And we'll have a look at creating a small Hello World program that uses all of these tools. Now remember, you only have to install these once. All right, the first one, installing Chrome. Open up Internet Explorer and navigate to the google.com/Chrome website. And from here, you can download the Chrome browser and accept the conditions to install. Follow the on-screen prompts, and this will go ahead and install Chrome. We need to use Chrome as it will allow us to print our code to PDF. It includes a built-in Save to PDF file option, which isn't available in Internet Explorer. When Google Chrome has finished installing, you can close Internet Explorer and close Chrome down and just return to the desktop. Okay, the next tool. Next thing we need is MinGW. Now this is going to give us some development tools that we need to be able to interact or to create some of the programs we're going to create. Now this is a little more involved than all of the other things you're going to have to install, so take some time with this. Make sure you follow all the steps. Now, the first bit's easy. We run the installer and we follow the prompts. Now this actually installs a separate configuration tool from which we can choose to install different tools that are available in the MinGW toolset. So once the configuration tool is installed, what you need to do is install the MinGW development tools, the MinGW base tools, as well as the MinGW G++ tools. So if you select those three options, just mark them for installation. You then go ahead and apply that installation, and the installation tool will go ahead and download all of the files it needs, configure those and set those up for your computer. It will take a while to download and install, so you can just leave that. I'll fast forward through that, and when it's all done, we'll move on to the post-installation setup. So we need to do a few steps to get MinGW set up correctly after the install's finished. All right, so now your install's finished, we need to run a post-installation setup script. So open up your Explorer and navigate, the file Explorer that is, and navigate to c://mingw. So navigate to that directory, and when you get there, scroll down and you'll find the MSys directory, double click to go into that one, and then double click to go into the 1.0 directory. In here, you should be able to see an MSys program. If you double click that, you'll get a prompt, a terminal window that appears, and we can type commands into this and get the computer to do different things for us. This is the kind of thing that we're going to be using to compile and run all of our programs. This is the basic MinGW or MSys terminal. We're going to install a separate one as part of these steps, one that has a few extra features like copy and paste, which this tends not to work too well with. All right, so once your terminal's open, you need to type a command. And the command we're going to type is cd space /c /mingw /msys /1.0 and then hit the enter key. What we've told the terminal to do there is to change directory. That's what CD stands for. So change directory into C drives MinGW MSys 1.0 folder. So the same place we navigated to in Explorer before. Now in this directory, we can run another command. So type /post install, one word, no space, /pi.sh. So that says to look in the post install directory and run the pi, which I guess stands for post install.sh file, which is a script file that contains a set of steps that it needs to follow. Now this in post install will go ahead and install or set up all the things MinGW needs to work correctly. So press enter and it'll prop up some text. You need to follow the prompts so that you're going to install it. And when it asks you for the directory, type in C:\\mingw and press enter. That's so that it knows where the basic or all of the other MinGW tools are installed. We're setting up the MSys tools here. All right. Once you're done with that, you can close the MSys window. And we'll open another one just to make sure that that post install is all set up and ready before we open it. Okay. Now we're going to install the console2 program. To do that, type mingw -get, one word, space install space msys -console and press enter. This is going to get all of the files you need to be able to install that console2 program. It will download those, just wait for that to finish. And when that's finished, what we type is console -config, enter. And that will go ahead and configure the console program and get it ready for us to actually use. When that finishes, we now have our console2 program. It will be called MSys so that it relates to MinGW's MSys console. We now need to find that program, and the easiest way to do that is to use your Explorer. So we can actually open an Explorer window in the current directory by typing Explorer space / and pressing enter in the terminal. Now it will run the Explorer program. / means the current directory. So run Explorer and tell it where the current directory is. And you'll see that pop up a window, and inside that we've got the MSys program there. You can double click that and that gives you the new MSys terminal window. And you can see we can copy and paste, and you've got right click, get a few extra options there. It's a bit nicer to use. Now, you're not going to want to navigate to this directory every time you need to run the MSys program. So best idea is to right click the MSys program and pin that to your start menu. This will make it easy to access from your start menu. So if we go to the start menu, you can see it over there on the right as MSys. If you click that, you'll get the MSys terminal. All right, that's by far the hardest part of this setup finished. So we're nearly there, bear with us. All right, now we need to install our compiler. We're going to be using the free Pascal compiler to start with in this course. We'll use some other compilers later on. Run the installer and follow the prompts. It's pretty simple. One thing you could do is remove the one that places a IDE shortcut on the desktop. We're going to use a different text editor, not the one that they provide. So just remove that option. Leave everything else the same. Click next, etc. Accept what you need to accept and finish to install the script. It will go ahead and install the compiler. All right, done. That one was easy. So next is Sublime Text. This is just as easy. Run the installer, follow the prompts, and we're done. So when that's installed, run the Sublime Text program, and we're going to need to install a few extra options inside Sublime Text. Okay, now to install package control. Open your web browser and search for Sublime Text Package Control. When you get the Google page that lists that, it should show you the installation page directly. Go straight to that page, save a bit of time. And what we can do is, if you scroll down, you can see that it gives you some code that you need to run in order to install package control. So it's actually really simple. If you just copy that text, just select it all, right-click and copy, or Control-C, Command-C, etc. to copy, then switch back to Sublime Text. And from View, show the console. This is where we can type some commands directly. So if we paste that command into that little text box down the bottom there, press Enter, then it will install package control. So it's not too hard. You've just got to wait a little bit. Once it seems to have installed correctly, this one doesn't show you much progress, but it'll take maybe a minute or two to install. Once it's done, you've got package control installed. So hide the console, and we can now use package control to install another package. So package control is a utility that lets us install what are called packages inside Sublime Text. And these packages add extra features to the text editor. And the one that we need is the feature that allows us to export our code to HTML. One thing that Sublime Text doesn't have is the ability to print things directly. So what we're going to do is export our code to HTML and then use your web browser to print it to a PDF file, which you can then submit as part of your weekly assessment for the unit. All right, so inside Sublime Text, to run the different commands inside Sublime Text, what we do is hold down 3 keys. So on Windows, you need to hold down Control-Shift-P. With those keys held down, it'll pop up a little box into which you can type the command that you want to execute. So we're going to use package control's install package command. We could type any part of that. Probably the easiest bit is to type install. So type install, and you should see the option package control install package. Select that and press enter. That will run that command. This brings up another menu once it's updated the packages. And that menu allows you to select which package you want to install. So you can have a look through there. There's heaps of stuff that you can install. Sublime Text is a really great text editor to use. In this case, we want the export HTML package. So type export, and you should be able to see export HTML. Select that, press enter, and it will go ahead and install the export HTML package. You can see the progress this time down the bottom left. So that's nice. You'll see that install. We're all done. We'll show you how to use this in a minute when we do a walkthrough of the language and the tools. All right, now we're done. The very last step we need to do is to restart your computer. Some of the stuff that we've installed in Windows means that the computer needs to be restarted. Don't skip that. If you do, stuff won't work. Not much fun. So just restart, everybody be happy. And I'll see you in a minute. All right. Now we can use all of this stuff we've installed to create a program. Good thing is, you don't have to install any more tools. Everything you've got, when it works, will work for the rest of the subject. So open Sublime Text, and we can create a new file, and we'll save it as helloworld.pas. PAS stands for Pascal, and that will tell Sublime Text that this is Pascal code, and it will syntax highlight that with that language, with the rules for that language. One thing to make sure you do is don't put a space. So it's not hello space world, it's hello world, one word, .pas. That's all just one word. The terminal and lots of programs you run from the terminal are difficult to work with if there are spaces in file names or spaces in path names. So avoid spaces pretty much for all file names. All right, I'm going to save mine into the desktop, but you might want to save yours into a documents, my documents folder or something like that. All right, we can now type in our program's code. And as you do this, you should see the text editor highlighting different parts of the text in different colors. This is because it understands the Pascal programming language and can therefore use that to give you some feedback on how you're going. So this program is program hello world, semicolon. We then have begin. I usually put the end in straight away. The end matches the begin. So we start at the begin, we end at the end, put a full stop at the end, and we will run one instruction, which is to call the write line procedure. So we type write line, write ln, no spaces, notice, open brackets, and then in single quotes, we'll put the text hello world, exclamation mark, close brackets, semicolon. So that tells, well, that's our instructions to the compiler for what we want the program to do when it creates it. All right, now we've got our code. Save that file. Use Control S or Command S on Mac. Alternatively from the file menu, but get used to the shortcut keys. It'll save you time. All right, now that the file's saved, we need to compile the program. So you need to do this from the terminal. So open the terminal. On Windows, use MSys or the MinGW terminal, and we need to CD to the location where you've saved the files. So I'm going to CD to my desktop. On Windows, that will be CD /C or CD space. So the space separates the commands, the parts of the command on the terminal. So CD space, where do I want to go? /C /users acane desktop. It's acane, that's because that's my username. So your username will be different. Type the appropriate thing in there. All right, now let's use the compiler to compile our program. Run fpc space -s2. That's an uppercase S, not a lowercase one. Uppercase S2. And hello world.pas. That tells the compiler to run, or to run itself. So we're running the compiler. The -S2 gives it options to tell it how we want it to compile the file, and S2 stands for a more advanced version of the syntax. So syntax 2, not the basic syntax, but the more advanced syntax. And hello world.pas is the file that we're going to compile. So it's going to compile the hello world.pas file and create a program for us. So when that runs, you can see we've got a hello world executable created on my desktop. So we can run that from the terminal /hello world and press enter. You could double click the file as well, but the terminal window will probably close straight away, so you won't actually see what it's done. So it's easier to run it in this terminal. Okay, so that's creating a program, compiling it. The other thing that you'll need to do as part of this subject or part of a unit will be to submit code. And when we submit the code, what we're going to want is a PDF version of the code so that we can annotate it to give you feedback, etc. So go back to Sublime Text and press Control-Shift-P on Windows and Linux, or Command-Shift-P on Mac OS. And this will bring up that menu of commands that we can tell Sublime Text. And we want to select the export to HTML command. So type export, and you should be able to see an option called Export to HTML Show Export Menu. Select that one, and then we're going to, you get a list of options, I'll select Browser View Color on Mac and Windows, or Sublime View Color on Linux. So with Mac and Windows, that will actually open up your code as HTML in the browser, which is really cool. It will have all the syntax highlighting, will have line numbers, be all fancy, all singing or dancing, etc. And we can then print that to a PDF. All right, now in your browser, we can print it to PDF. So in Windows with Chrome, what we can do is from the file menu, choose print, so print, and change the destination. Instead of being a printer, change that to save to a PDF file. That makes it super simple. It'll do all the work for us. We then click the save button, type in the file name that you want, and presto, we have a PDF copy of our code, nicely syntax highlighted, etc. And that PDF file is what you would submit in order to get feedback. All right, we're done. So we've had a look at all of the tools that you need to install for Windows, and you've seen how to use Sublime Text to write your code and to export that code to HTML. We've seen how to use the terminal to compile your program using the free Pascal compiler, and how to run that program. And we've looked then at using the web browser to print your code to PDF. So that's pretty much everything we need to be able to do. Now we can focus on what we actually do inside that program's code. And that will be what this unit's all about. So thank you very much. I hope that helps. And if you have any problems with the installation, feel free to contact us on the discussion board, etc. All right, good luck.
This has been a Swinburne production. Swinburne University of Technology.
Hi and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Jake, and in this video we'll be taking a look at compiling our own programs.
When we create our own programs, what we do is we type code in using a certain programming language. We call this source code. But the source code isn't something the computer can run directly. So what we need to do is convert our source code into machine code using a tool called a compiler.
Yeah, and to run this compiler, we need to use something called the terminal. So let's just have a quick look at our Hello World program we've written.
So here's Hello World. This is written in a programming language, in this case, the Pascal programming language. And it lists out the instructions for the computer to execute. In this case, it's just going to print a message out to the terminal.
Yeah, so we need to use the terminal to run the compiler. So let's have a quick look at the terminal. And there's really not much going on. So do you want to just have a quick explanation of the terminal?
So the terminal allows us to run commands via a command line interface. So we can enter text, and that text is a command, tells the computer what we want to do.
Yeah, so the very first thing we need to do is move to the location of the source file.
Yeah, so the terminal runs in a directory. It has a working directory, and the working directory, we want to make that match our source code directory.
So currently
so we can,
okay.
Yeah, so we can change into that directory using cd. So the cd command allows you to change directory, and it's in your users document, your user directory, sorry.
Yep.
So users Jake in this case, and documents.
Yeah.
And that matches up with the terminal. With the
Finder.
Yeah, that matches up with Finder. And so what we can do is we can actually list the files in this directory using the ls command.
So just like you'd see in the Finder, all the files and folders in the window.
So in Explorer, in Windows, or Finder in
you
Mac.
can see them in the terminal right here.
Yeah, and we can see that the Hello World file is there.
So how do we convert this to machine code?
So we can run the compiler. So the compiler for Pascal is going to be the free Pascal compiler.
Cool.
So the free Pascal compiler, FPC, free Pascal compiler.
Yep.
And we give it one option. And the one option we need to give it is -S2.
Cool.
So that tells the compiler that we want to use a more advanced version of the syntax. The free Pascal compiler can actually compile a number of different Pascal dialects. This is the one that we want.
Yep. And what else do we need to give it?
We also need to give it the name of the file that we want to compile.
Because it needs to know to convert this file.
That's correct, because we could have had lots of Pascal files. It needs to know which one.
So when we run this command, it will compile our Hello World program.
Yeah, so if we do an ls now, or we look in Finder or Explorer
Yep.
on Windows, we should see a program there, the Hello World executable.
Yep, so that has been generated from our Hello World source code when we ran the compiler.
Yeah, and we can run that now. You need to put // on Unix. Windows doesn't matter quite so much. Dot means the current directory. So // means
Yep.
in the current directory, run the Hello
Run
World
it.
program.
Yeah, exactly.
When we run that,
say Hello World. It's works.
Awesome.
Cool. So what else do we need to do with the terminal?
Okay, so one other thing that we need to have a look at in the terminal is the way that we can compile Swingame programs. So Swingame is a library that we're going to be using to help you learn how to program.
And it has a more involved compilation step. So there's a script written that we need to run, and that will do the compilation for you.
Yeah, so it uses a build script. So if we move into, I've got a directory here. One thing we can do when we're moving into a directory, I want to move into the Swingame starter directory inside your documents folder.
So you don't need to write the entire directory or path to get there. It knows, look for Swingame starter file in the folder that you're already in.
Yeah, that's right.
Cool.
So here it will now jump into the Swingame starter folder.
Yeah.
And if we do an ls, we can see the files that match those that are in the actual directory.
Yeah, and while you don't see a Pascal file here, you do see the build script, and that will know to run any Pascal file in the source folder.
Yeah, so we can run the build script the same as we ran the executable file before. So we say // in the current directory, run the build script.
Yeah, and when we execute this command, Swingame will build the Pascal file inside the source folder.
Yeah.
And if there was more than one, it would give you the option to select which one.
Yeah, that's correct. You can then run it by using // run.sh.
Yep.
And that will actually run the program, and the window will pop up or whatever you want it to do.
Cool.
One thing to note that makes this much easier to work with is tab for auto-completing.
Yep.
So when I was moving into the users folder, you can do US for users, press tab. If it isn't unique, so in this case I need to put in a few more characters. Users. Yep. But if we do Jake, JA,
Yep.
and then we press tab, it will auto-complete. Documents, DOC, tab, it auto-completes.
Cool.
So tab is really very useful. The one other thing that's useful to know is the up key to cycle through previous commands.
Yeah.
So you'll find you'll often build and run.
Yeah.
Build, run,
And you
build,
can
run,
just
build,
switch
run.
between them.
Just switch between the two.
So that's been a really quick look at the terminal. There's a lot of other powerful functions that it performs for us, but they're the basics to get you building and compiling your own programs.
Hope you enjoy this, and we look forward to seeing you again soon.
Bye.
Bye.
This has been a Swinburne production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Ruben, and in this video we're going to be looking at syntax.
We've been teaching programming for a while, and one of the key things I think when you start to learn to program is to understand the idea that programming is much more about concepts, so programming concepts, than it is about programming language.
Yeah, and that sounds really powerful because, you know, once I learn these concepts, I can apply them to any language. So rather than just being stuck with one language, having an understanding of these concepts will allow me to adapt that to many languages.
Yeah, that's right.
So what I really need is, I'm not at that level yet, so what I need the tools to be able to convert my concepts into code.
Well, what we need for that is a way of understanding the rules of the programming languages. So each programming language has its own set of rules for how its code needs to be typed into the computer. And that pretty much tells you if you want to create this thing in your code, so you want to create, say, a program in your code, you type this. If you want to create this other thing, like a function or a procedure, which we'll talk about later, you type this. So what we've got in order to help with this is there's a book that we've created called The Programming Arcana, because we think programming's pretty magical.
Yeah.
And the Programming Arcana includes in it syntax diagrams for a number of different programming languages. And so you can use this to pick up sort of any of those languages. All right, so in order to create a program, what we need to look up in the syntax rules, so in the programming arcana, is the syntax for what? It's the syntax for a...
program.
Yeah, tough, hey?
That-
All right, so here's the syntax. We'll start with a Pascal program. So we'll
Yeah.
write in the Pascal language.
Yeah.
So here is the syntax diagram related to the rules for Pascal in order to create a program. And it's called a railroad diagram. So you follow along the arrows. You start at the start and you go to
Yeah.
the end.
Makes sense.
Yep. And along the railroad, you'll encounter different symbols.
Yeah.
Yep. These rounded rectangles, which are grey, have things that we type directly in the code.
Yep.
So for our Pascal program, what are we going to type first?
Program, I gather.
Yes.
Yeah.
Yep. This is the good thing about Pascal. You want to create a program, so you type program.
Yeah.
Yeah. It's not very cryptic, which is nice. All right. So that grey box just means that. So in our code at the moment, what we have is just the word program.
Yeah.
And
Yep.
so we've got past that point, and you separate it by white spaces. So tabs, new lines, spaces. So
Yeah.
I think at this point we put a space before the next thing. And so the next thing is,
We've got an identifier.
all right, now that's in a different coloured,
Yeah, it's red or pink. I
Yeah.
don't know what you call that, but
yeah, I don't know either, pinky.
yeah.
Yeah, anyway, the pinky coloured rectangle is actually another rule. All right, so this is another thing, a term. So in programming, an identifier is the name of something.
Yeah.
And there is a special rule in Pascal, as in other programming languages, for what an identifier looks like. And so we need to find the identifier syntax, and it tells us an identifier looks like this.
Okay. So it's got to have, it's got to start with a letter.
Okay, well, we've actually got two options here. Notice that if you follow that railroad from the
Yeah.
very start,
Yeah.
you've got that fork. You could go one way or the other.
All right.
So it could start with a letter or an underscore. That was very difficult. That is actually an underscore. It's not a minus.
Okay.
It's the underscore, all right?
Sure.
It's hard to tell the difference in this, but that's what it is.
Yep.
So so it's a letter or an underscore.
Yep.
All right, now we've got two different symbols here. So one of them's the square and one of them's the round one. Which one would I type directly in and which one is a different rule?
The round one
Yeah, so the underscore,
is what you would type in, and the letter that's a separate rule. What do you mean?
yeah, that's right. Yeah, that's exactly it.
Okay.
So letter is a separate rule, underscore I type in. So if I want the name of my program to start with an underscore, then I can put an underscore.
Yeah.
What do we want to call this program?
Test program.
Yep, okay, so test program, that means we're going to type a letter.
Yeah.
Yep, so we can go to letter, and a letter is another rule. This is how pedantic computers are, all right? Computers are unintelligent. They have no brains.
Okay.
They just follow instructions, and so it needs to be incredibly detailed.
Yeah.
And so the syntax for a language is right down to every single character that you type in.
Mm-hmm.
So a letter is literally a letter. It's A, B, C, D, etc.
Yeah.
Yep. So we're going to start it with T for test program.
Yep.
Yeah. Once we follow the syntax, well, when we finished our letter, that gets to the end of the letter.
Yep.
We can now go back. We continue along the syntax diagram. And so we could call the program just the letter T,
Yeah.
or we could call it just underscore.
But it's not very meaningful.
Yeah, that's right.
Yeah.
So we can call it test. If we follow this down, we can go through letter again.
Yeah.
We can pick up T, E, S, T,
Yeah. Yeah.
P, R, O, G, R, A, N, yeah, etc.
Yeah.
And so the identifier can be test program. Now, in the future, the idea would be you only need to look these up sort of the first few times you encounter it until you can work out what the sort of overall rule is.
Yeah.
So we can see here the rule for this is effectively it's got to start with a letter or an underscore, and then it can have letters, digits, and underscores inside it.
Yep.
So we could have test program, but we couldn't have test space program.
But you could have test underscore program.
Yeah, that's right. You could have test underscore program. We could have test 23 program.
Okay. Yeah.
But I couldn't have 23 program. Yeah.
Yeah.
Because it can't start with a number.
No. Yeah.
Yeah. Okay, so that's now our valid identifier. So at the moment, what we'll have in our code is program followed by test program.
Yeah.
And so we now go back to the program syntax. So we finished our identifier. What comes next?
That looks like a semicolon.
Yep. And notice it's in the grey it's in a grey rounded rectangle.
Yeah.
So that means, what do I do with this?
Well, it has to have that.
Yeah, we'll just type it directly
Yeah,
in. It's,
yep.
I don't need to look up what a semicolon is. It just means
Yeah.
semicolon.
Okay.
Yeah. And what could come next?
We could, looks like, what, a user's clause? A block, rather, actually.
Yeah, no. So it could be a user's clause or a block, couldn't
Yeah.
it? Because we've got an option here. We can put a user's clause in. And so if I did, it would look something like that.
Oh, yeah, yeah.
Yeah. And that's because a user's clause has users followed by the name of the user unit identifier, which is an identifier. And then I could have a number of those separated by commas.
Yep.
And then a semicolon. And so this says this, at the moment, this program uses SwinGame, which is a library that we're providing that has sort of functions for audio, video, networking, a whole bunch of things. But if we don't want that, then we don't need that users clause.
Yeah.
And so after the users clause, whether we have it or not, the next thing is going to be our block.
Yeah.
And so we can find that rule just down here.
Yep.
And so block starts with,
Begin.
yep. So I just type begin in, don't I?
You do?
Yep. Yeah.
Cool.
And we could, seeing as we're doing the begin, we could probably also put the end, because each block is a begin end with a number of statements in between.
Yeah.
So we have begin, we have some statements, and each statement is a command that tells the computer what to do.
Yep.
And we then have an end at the end of that. And so we can put our begin end. And after our block, we end up with we'll come back and put the statements in later.
Yeah.
At the end of the block, we have a full stop.
Okay.
And so that's sort of the skeleton of our program's code.
Yep.
So in Pascal, that's what we type in order to create a program.
Mm-hmm.
The statements then, we could have a look at, well, what is a statement? A statement, at the moment, we have the option of a statement being a procedure call. And when we execute, that's another rule.
Yeah.
When we execute a procedure call, we need to put the name of the procedure.
Yep.
And then we can have some brackets with arguments, which are values that we provide to those procedures. And so here we've got write line, which is a procedure in Pascal that prints things out to the terminal. And inside the brackets, we can put values that we want to print out. So this is printing out hello world. But expressions, which are values that we use inside our program, you can calculate them in, there's many different types of expressions. So you can have things that are numbers, like 73, or, if you want real numbers, you could use something like 2.1.
Yeah, yeah. Or strings even.
Yep. So like hello world or Fred.
Multiplication, addition, division.
Yeah.
Yeah.
So any of these things which are the sort of mathematical expressions, so that they calculate values or they are a value, can be placed in any of those points where you've got an expression.
Yeah.
Yeah. All right. And so we could call, in our program, we could call the write line procedure, and maybe we could call that twice.
Yeah.
And so this should be valid syntax, because what we have at each point is we've followed the rules.
Yeah, yeah.
If we compile that now, when we run the compiler, you can see that we get some output to say that it's compiled successfully.
Yep.
And the program is completed successfully.
Yeah.
Now, if we make some mistakes, like imagine I don't have the end.
Yeah.
Yeah. And we then save that. If I recompile it, you'll get a compiler error.
Okay, is that because the compiler's looking for an end?
In this case, yeah.
Yeah.
So the errors can be cryptic sometimes,
Yeah.
but in each case it tries its best to tell you where it went wrong. But remember, it's very, very, it's more than stupid.
Yeah.
It's unintelligent. So it will do the best it can to sort of try to output some meaningful message, but it can be quite cryptic. And that's why it's really good to understand some of these basic programming terms.
Yeah.
And I think the really, really key ones are identifier,
Yep.
which is the name of something in your program.
Yeah.
A statement, which is...
Something that the compiler executes?
Yeah, that's right. So it's an instruction.
Okay.
This is a command. This is what I want done. Do this now. Expression is the other really key one, which is a value, something that we calculate. So often the error will say something like, this statement was expected.
Yeah.
So that's something about a command. Or invalid expression.
Okay.
It means that calculation doesn't make sense.
Yeah.
You've got something in there that doesn't compute. Yeah. Or identifier not found,
Which
Meaning-
means that that doesn't exist.
Yeah, can't find that name. You've
Okay.
got a name there. You've either spelt it wrong. You've got something's wrong with the actual name.
Yeah.
Inside that identifier.
Yeah.
So those parts of the syntax are really important to understand.
Cool. So I can definitely see how we've applied those concepts to one language. What about applying them to another language?
All right, well, let's have a look at a C program. So this is the code for a C program.
Okay.
And what we can do is we can have a look at the syntax rules that we use to, and this in fact is exactly the same program.
Yeah, well, it looks very similar, bar a few differences.
Yeah, so if we look at the syntax rules for C, we can see that in C, a program optionally has some header includes.
Yeah.
And this gives you access to libraries.
Okay.
Now, Pascal actually gave you some libraries for free.
Yeah.
C doesn't give you anything for free. So you need to tell it everything that you want.
Yeah.
And the one to print things out is the standard IO library.
Yep.
So we have to hash include that. So that's our header include. That says give me access to that library. And we can see that's just followed those rules there.
Yeah.
In order to do that. Once we've got that, we then have a main function. This is where C programs enter, just like the begin in a Pascal program. And so we just type the code in here.
Yeah.
And we have a block.
That's exactly the same as a Pascal program.
Yeah, that's right. That's very similar, isn't it? But a block, instead of typing begin, we have a curly...
Braces,
yeah,
yeah.
a brace. Instead of end, you have a close brace.
Yeah,
It's
yeah.
so massively different. Nobody would ever, be able to pick that up on their own. Sorry, being very sarcastic here.
Yeah.
Yeah. And we have statements. So notice that C still uses the idea of statements. It still has the idea of identifiers. If we look, say, at a C procedure call, you've
Yeah.
got the name of the procedure, which is an identifier. You have
Yep.
brackets, which is like the same as Pascal, and then you've got arguments. This terminology is pretty much the same across programming languages.
Yeah.
So all that's different is some small things like braces instead of begin and end. The bigger thing, though, I think that's different are like printf.
Yeah.
So the different features or different things the libraries provide you do change, and that takes a little bit of time to pick up, but the core of the language is the same.
Okay, so basically I can do the same thing in many different languages. It's just getting used to the visual differences in syntax.
Yes, that's it. Yeah, so that's why it's really important to focus on understanding the concepts first. Don't stress too much about the syntax. Pick an easy language that's nice to work with, like Pascal. Work through that one. And then when you finish that, you've got the idea. It won't take terribly long.
Yeah.
It will only take a couple of weeks. You can then pick up other languages really quickly and build upon that really solid foundation of understanding the concepts.
Yeah.
All right, that's it for the basic overview of syntax. What you probably want to have a look at next. So what are some of the other videos we've got?
Yeah, so we've got some videos on the compiler, installation videos to help you get everything that you need set up and going, writing programs, and if you're ahead of all of that, why don't you check out the video on variables?
Yeah, cool. All right, and that's all we have time for this video on syntax. I hope you've enjoyed it, and we'll look forward to seeing you again soon.
Bye.
This has been a Swinburne production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Ruben, and in this video we're going to be looking at programs and sequence.
So far, we've seen how we can compile programs from the terminal using the command line compiler and using our build script for our Swing Game programs.
Which is cool, but what exactly can I code into my programs?
Well, there's a whole lot of things that we can code into our programs, but I think where we want to start is to understand that the computer runs our programs as a sequence of instructions. And so I think that's where we can get started.
Okay. What I would like to do then, using Swing Game, as you said, is I'd like to make a basic illustration of my house. So can we do that?
Yeah, let's get started with that. So here what we've got is an empty program, has no instructions in it at the moment, but between the begin and end, we can provide a sequence of instructions for the computer to execute. The one instruction we can use at the moment is going to be called a procedure call.
And what exactly is a procedure?
So a procedure is like a small program. It's actually another list of instructions that performs a certain task. So let's add in 2 instructions to start with. Open graphics window and delay. So open graphics window, we pass it 3 values, and when we call that procedure, it has all of the instructions to make a window appear on your computer. Whereas the delay procedure has all of the instructions to tell your computer to wait for a certain amount of time. And so we pass in 5,000 for delay, which is the number of milliseconds to wait. With Open Graphics Window, we pass in 3 values, being the title of the window and the window's width and height.
Cool.
So if we switch to the terminal now, and compile and run this, we should see that program work. And so when we compile it, we use build.sh. You have to use cd to change into the directory first, remember that. And when we run it using the run script, it appears and we can see the window for 5 seconds.
But it doesn't really have much in it yet. So my idea was to draw our house. So where do you suppose we could start with that now that we've got our graphics window and a delay?
So with this, remember it's a sequence. So we want to show the picture after we've opened the window, but before we delay.
Okay.
So we would put the instructions in between. So we could start off by say, let's clear the screen to white. So
Yep.
there is a procedure called clear screen. We call clear screen. It's going to clear that window to white. And we can then add in one more, which is refresh screen. When we call refresh screen, it shows everything that has been drawn previously onto the screen. This way we can draw part of your house one piece at a time, but then only show the whole picture when it's finished.
Cool.
So let's switch back to the terminal, compile with build script, run with the run script, and we can now see the window open and the screen is cleared to white.
Yeah, yep. Alrighty, well, let's start off with putting in, say, a hill. So how could we do that?
So there's a number of drawing procedures. So there's fill and draw procedures. So for each a number of different shapes. So we have fill ellipse, fill rectangle, fill triangle, as well as draw ellipse, draw rectangle, draw triangle. Each of these takes a different number of parameters based on the shape. So the ellipse takes a color, as well as the X and Y position, which is the distance from the left-hand side of the screen and the distance from the top of the screen. And then they take in the size. So an ellipse, we need to know the width of the ellipse,
Yeah.
and the height of the ellipse. And so that's those extra parameters there. So in this case, it's going to draw the ellipse at 0, 400. So 0 pixels from the left, but 400 pixels from the top. It's going to be 800 pixels wide and 400 pixels high.
And it's going to be bright green.
Yeah.
Cool.
So
now,
if we run that, we can see that circle drawing.
Sweet. And that's exactly what I do see there. So now I could draw the rest of my house by adding in a rectangle and a triangle for the roof.
Yeah, that's correct. And so the key bit to remember, though, is that you've got to put it in the right sequence. So if you put the drawing of the rectangle before the drawing of the ellipse, then the hill would appear in front of the house. So the house would be behind the hill. Whereas if you do it the other way around, the house will be on top of the hill.
Cool. So it's sequenced just like you said. We fill the ellipse first, and then we can fill the base of the house, and then we can put the roof on.
Yeah, that's right. And so the key bit to remember for programs run as a sequence of instructions. It starts at the top, and as the program executes, each instruction runs one after the other. So when we run this program, what happens? The window opens, it clears the screen, it then fills the ellipse, it fills fills the rectangle,
Yep.
then fills the triangle, refreshes the screen, which shows everything to the user, delays for 5 seconds, and after 5 seconds, the program ends because we've reached the end of the instructions.
Too easy. So I guess that wraps that up then.
Yep, so that's it for programs and sequence. Our future videos.
So we've got a video on creating your own procedures. So now that you have an understanding of what they are, you can go ahead and create your own. And if you haven't checked them out already, you should check out the videos on compiling your code as well as navigating with the terminal.
Okay, hope you've enjoyed that, and we look forward to seeing you again soon.
Bye.
Bye.
This has been a Swinburne production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Cliff. And in this video, we'll be looking at creating our own programs and procedures.
So far, we've seen how to compile programs and have those programs, as a list of instructions that perform things in sequence. And we've been able to call other procedures to perform tasks like some drawing things as well as printing things out to the terminal.
Yeah, I've been getting a hold of this calling procedures situation. I like it; it's useful, but I think it'd be really good if I could create my own procedures. That way I could create a little bit more meaning in my own code. I could reuse sections of my own code. All of these kinds of things.
Yeah, well, definitely that's what this video is about. So
Awesome.
we can create our own procedures, and that can help you sort of encapsulate all of the actions needed to perform different tasks in your program. And those procedures will be able to be reused. You don't have to code them multiple times. Get it right once and just call it anytime you want to.
Okay. So here I've got this this wee program that I've been making. I was tasked with making a Morse code program. Well,
Tell me what it's saying.
It's meant to say YOLO.
Okay.
You can't see that?
Can you?
No, that's really one of the problems. And I made tons of mistakes when I was doing it anyway, and I was having to refer back to the Morse code alphabet. And I think there might be a better way to do this.
Yeah. So, one thing we could do here is break this up into procedures, and so we can have sort of the instructions in a main procedure to start with. But I mean, it's affected. What we've got is pretty much the same.
Yep.
Now, what are the main sort of tasks inside your Morse calling program? What are the most basic ones? Maybe we'll start there, and we can then work up to more complex procedures.
Okay. Well, looking at the smallest sort of package of information in there would probably be the short signal and the long signal and the breaks.
Yeah. Okay. So what we could do is create procedures to represent the actions that need to be performed when those tasks, or when you want those tasks performed. Yeah?
Okay. Yep.
So, I mean, in this case, there is only one instruction in each of those. But the good thing is later on, if we want to change how that works, we only got to change it in this one place, and everywhere else would then have that change reflected.
Okay. Yeah, and I can see that the main procedure is a little bit easy to read now, but
we got the idea now that it's making long and short signals and delays between characters.
Yeah.
It looks a bit more meaningful, but
we've still just substituted each of those characters with my own procedure, so we haven't really changed much of the program. Could I make a procedure to make each letter?
Yeah, so that's definitely what I think we would do next. So what we could do next, instead of just having the long and short signals being called in main, what we could do is create our own procedures to signal each of the different characters.
Oh, so you can have your procedures calling other procedures.
Yes, yeah. So,
oh, sweet, Inception.
Yeah, yeah, pretty much. Yeah. So now we can see that it's printing. You've got a procedure for each of the different letters.
Yeah.
And the great thing is you only need, say, the signal O once. And once you've got it right, it's 3 long signals.
Yeah. Okay.
Yeah,
So
you
I've
can then
actually
call it multiple times.
I've saved 3 lines of code already.
Yeah.
Sweet. And it's much easier to read now in main. You can actually, ignoring the signal section, you can see, YOLO. So that's, awesome.
Yeah. And the great thing now, as I said before, we could actually change the whole way that this works. So at the moment, this is printing out to the terminal.
Yeah.
But, I mean, you'd only have to make a very minor change to have this work with a, actual audio. So we could change the way the short and long signal work so that they play sound effects using the Swin Game library that we've provided.
And so just by replacing those write commands, those write procedures with the play sound effect, that will affect all of the the signal Y and the signal O as well?
That's correct, because each of those is actually calling those long and short signal procedures.
I think that would that's going to save me so much time in development later.
Yeah. Well, the good thing would be if you had a bigger program, if you made a mistake in one of your procedures, when you fix it in that one spot, it fixes it everywhere that called that one procedure. So you don't have to sort of, if you've duplicated the code all over the place.
Yeah. So you can just fix
you don't
it
have to
once
find it
and it
everywhere.
fixes it all, yeah.
Yeah. All right, Cliff, do you want to show us how this one works?
Yeah, sure thing, Andrew. So the program begins, and we start off in the main procedure. And the first thing that it does is it calls the procedure that I made called signal Y. So it heads up here, and then the first thing that it does is calls the long signal procedure.
Okay,
so
yep.
We're jumping around a bit here, but
Yep.
I hope you can bear with me. So we head up here, and the procedure begins, and it plays the sound effect da. After that, the procedure ends, and it returns to the procedure that called it.
And so the signal Y procedure remembers which instruction it's up to. So it now runs.
Short signal.
Yeah.
Yep. So once again, short signal is called. And
So it goes on top of the stack.
That's right. Yeah. So as you can see over here, yep, you've got the signal Y, and then it's calling short signal. So it begins, plays the sound effect dit.
Yep.
It ends, and once again returns back to signal Y.
Yeah.
So now you said that it keeps track of which line it's in signal Y as well. Yeah, the stacks.
That's right, yeah.
The stacks managing all that. I don't
That's
need
it.
to do
That's
that.
all in the stack, yes. The compiler's remembering all of these things for us.
Brilliant. Love it. All right. So next thing, I think, oh man, I wish I could remember as good as the stack could. I think we're up to long signal.
Yeah, long signal, yep.
Yep. So we head back up to long signal. Same situation again. It's called, it begins, plays the sound effect da.
Yep.
Ends, returns back to
Signal Y.
signal Y. Long signal again.
Yep.
Man,
I think we get the idea
I'm
now.
so glad
Yeah.
that this is automated. Like if I had
Yeah, no, yeah. It is pretty cool. You just say do this and it does it for you. Yeah, and so now when signal Y ends,
Yep, it's going to return to the procedure that called it.
which was,
Main.
that's right.
Yep, so we're back to main. And we're going to call a character delay, so that's just a space so we can
So
separate
it goes
each
up,
of the
yeah,
letters.
plays the character delay
Yep.
procedure. And so this is the same, but now, it's just calling fewer of our own procedures.
Yep.
It still calls delay, which is a procedure, and it probably calls other procedures that we don't know about.
Cool.
Yeah. And so the process just continues, doesn't it?
Yeah.
For a signal O, and it calls through all of the different, or in this case, the 3 long signal procedures.
Yep. Character delay, and then signal L, character delay, signal O.
Yeah.
Yeah. Cool.
All right. And then when we've got nothing left on the stack, what must that mean?
Well, I guess if his procedure main has ended, it will go to the end of the program.
Yeah, and that's it. So that's how the program knows when it's over.
Oh, cool.
Yeah. All right. So here is another example. So in our YOLO program, we could put all of the actual
Signals themselves, yeah.
YOLO phrase
Yeah.
into its own procedure, which prints out each of those characters. So if you wanted to say YOLO 10 times,
You don't
just
need 10
write-
lines.
Yeah, that's right.
Well, and all of the accompanying procedures.
Yeah.
Yeah. Okay, cool. Here's one that I've got here that's taken a simple house drawing program,
Yep.
and I've split up all of the sections of the house because calling the swing game procedures did look a little bit confusing in main. I've just separated.
Which just
those
makes it
into-
much clearer, doesn't it? If you look in main, we can see that you're drawing some sky, you're drawing a hill, you're drawing a house.
Yeah, and it means that if I wanted to change the color of the sky, I know exactly where to go.
Yeah,
Which,
yeah.
yeah.
You don't have to work out which one of the different, fill rectangles.
Was it the
draw
rectangle?
rectangles,
Was
yeah.
it the clear screen? Yeah.
Yeah. Cool. All right, that's it for procedures at the moment. We will come back and look at a lot of these things in more detail later to make things even easier.
Okay.
Because that's always the idea. I mean, we're trying to make, do more with less.
That's a good programming principle.
Yes. Yeah. So we will come back and look at all of these and different things we can do with them. But
Well,
that's the
what-
basics of procedures.
What should I check out next?
That's a very good question, Cliff. So next, watch the variables video. Otherwise, if you haven't already checked them out, have a look at our compiling videos, and we have a bunch of setup and install videos as well as a sort of an overall welcome to the series.
Yeah.
All right, I hope you've enjoyed that, and we look forward to seeing you again soon.
See ya.
This has been a Swinburne production. Swinburne University of Technology.
Hi, welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Jake, and in this video we'll be looking at variables.
So far, our programs have been a list of instructions inside which the data has always been fixed. So we've actually typed all of our data into the program itself.
And that sounds really limiting. So wouldn't it be great if there was somewhere where we could store our data in our program so that we could maybe change it later?
Well, the great thing is we can use variables. Variables allow us to store data inside our programs. We can then read that data back and change the values inside the variables as well.
Great. So I've actually been writing this program, or I tried to write this program, but when I wanted to get the user's name, I just didn't know how to go about it. So is this a case where we could use variables?
Yes, so we could use a variable here to store the user's name inside the program, and then you can use it later on. And so here we've declared the variable. When we declare a variable, we actually allocate space. We ask the computer to allocate a space to store some data. And so here we give the name to the variable. So this is the username variable, and it's going to store a string, so a piece of data.
And I can name it whatever I like?
That's correct. There are some rules. Basically, if you stick to starting with an alpha character and not having any spaces, you should pretty much be right.
Okay. And what's with the string?
So the string says what kind of data we're going to be storing inside the variable. So a string in this case is textual data. So the name might be Fred or something like that. That's text. We store that inside that. We can store that inside the variable. Other types are things like integers for whole numbers, and you've got other types like double, for example, for real numbers.
Okay, cool. So now that I have this space for my name, how do I put my name into it?
For that, we can use an assignment statement. So anytime you want to change the value of a variable, the only way of doing that is through an assignment statement. Somewhere, there has to be an instruction to say, put a value into this variable. And that's what the assignment statement does. It says the value on the right-hand side, store that into the variable on the left-hand side. So in this case, we're going to call this read string function here, and it's going to return us back whatever the user typed at the terminal. And we can take that and store it into the username variable.
Cool, so that's exactly what I was looking for. So now I have the person's name inside my variable.
Yes.
So now that I have the name, how can I use it? So I want to tell the person that I actually know their name. How do I do that?
Well, the way we can do that is just by using the variable's name inside an expression where we want that value. And what will actually happen is, so in this case, we're writing out that the user's name is an awesome name. That won't print out the text username. It will print out whatever is stored inside that variable. So here we're saying read the value from that variable and use it at this point in the program.
Cool, so that's exactly what I wanted. That's great. So I've also written this program for my little cousin who's learning at 6 times tables, but it's a bit limited at the moment. I can change it using variables so that I could use any times table.
That's correct, yeah. So rather than having 6 hard-coded in this program and the answers hard-coded, we could actually calculate the answer and use a variable to determine which times table we want to use.
Okay, so we should use an integer variable?
Yeah, so in this case, we can have the times table as a whole number. So the number that we use will be a whole number, so it can be an integer. We can declare a number variable, and we start off with 6. So we can store 6 in that variable.
Because I want to make sure it works.
Yeah. And then rather than printing out the hard-coded answers here, we can calculate the answer. So the first one would be 1 times the number. And then the second one we can use 2 times the number, etc.
Cool. So what if I want my little cousin to change the number whenever she runs a program?
All right, well, rather than up here where we've got our assignment statement, which is storing the value 6 into number, we could change that to use read integer. So read integer is just like read string. It's a function that we're providing in this case, and it will read in a number that the user types in and return that number to us, and we can store that number into that variable.
So when the program runs, the user can put in the number.
Yes.
But this isn't right because it's saying 1 times 6 still.
Yes. So what we can do here, rather than printing out 6, because now that we're actually using a number that's going to change as the program goes, we can, in that place, put the value of the number variable. Right. So we're going to print out 1 times the value of whatever is in the number variable equals 1 times that value, and then 2 times, etc. for the other ones.
Cool. Perfect. So now that she's getting a bit better at her times tables, is there a way that I could let her start at any number, not just 1 every time?
Well, yes. So what we could do is use another variable. So in this case, we've got our number variable, which is storing our integer, but we could also create a second variable, maybe we'll call that the multiplier, and that gives us two separate variables. So each variable stores its own value, like two placeholders.
Cool.
We could then read in another integer, so your cousin or whoever it was, sorry, I've forgotten, can enter in whatever they want as the starting value. We can store that using the assignment statement, store that in the multiplier, and then we can use that multiplier in our calculations. Now, one thing we will have to do there is increment the multiplier between each one of the values that we're printing out. And so we can actually do this. Multiplier is assigned multiplier plus 1, and that might seem a little strange if you think about it from a mathematical point of view. But what this is doing, you got to remember, is the assignment statement. So it's first executing the right-hand side, which is multiplier plus 1, and then storing the value in the left-hand side.
So if I started at 20, it would now go to 21.
Yeah, and then it would go to, when we run it again, it would go to
22.
Yeah.
Cool.
So Jake, did you want to talk through how this works?
Yeah, sure. So when we start the program, we jump straight to the main.
Yep.
And when we declare our variables, we're declaring a number variable and a multiplier variable.
Yeah, so it's going to allocate space for two integer variables. Now the type here determines how big that space would be. So these are two variables big enough to store one integer in each variable.
Cool. So then when we run to the next instruction, we are assigning an integer to our number variable.
Yeah, so the result of calling this read integer function, so whatever the user types in, whatever number they type in at the keyboard, will come back, and that number will be stored into the number variable. So what number do we want to...
So let's say we store 53.
Yep, so 53 would then be assigned to the number variable. And then we go to the next instruction. So it's going to execute read integer again, ask the user what number do we want to start at.
So my cousin's like really good, so I want to do 27.
Okay, cool. So 27 will then be assigned to the multiplier. So that value is put... The way you can think about it is like the variable is sort of like a box. And this is putting the value into that box.
Cool.
Yeah, so put the value 27 into the multiplier box.
So this line prints out the equation.
Yeah, that's right. So what it does is when it prints it out, it's going to print out... So we've got multiplier first. So it reads the value of the multiplier variable there. So that's going to be 27. Then it prints out the x. We then read the value of the number variable. So that's 53. Yep. Equals, and then it's going to print out the result of this expression. So multiplier times number, it has to be calculated before it prints it out.
Right.
So what is the value of multiplier?
27.
Times, what's the value of number?
53.
So that is...
1431.
Cool. So it's going to print out 1431.
Cool.
Now on the next line, we then need to increment the multiplier because we've already done 27 times 53. We now want to do...
28 times 53.
Yeah, that's right.
So we add 1 to the multiplier.
Yeah, so this adds 1 to the multiplier. So multiplier is currently...
27.
Plus 1 is...
28.
Store 28 in the multiplier.
Right, cool.
So now the multiplier is 28. When we do the equation again, we print out the multiplier, which is now...
28.
Yep.
Times 53.
Times the number, which is 53. Yep. Equals multiplier times number. So multiplier is...
28.
Times 53 is...
1484.
1484. Excellent. You seem very good at this, Jake.
Well.
All right, so on the next slide now, we now need to go to the next multiplier, yeah?
Right. So we do the same thing again.
Yeah, so this time reads the value of the multiplier, which is...
28.
Yep, add 1.
29.
Yeah, store that in the multiplier. So now the value of the multiplier variable is 29.
Times the
And
number.
we repeat that, so the outputs... I think you get the idea now.
Yeah.
The output outputs the value from the multiplier variable, 29, times the number, which is 53, which is...
Something like 1537.
Yeah. What about 32 times 53? We can calculate that one later. All right, so this would then continue on until it gets to the end of the instructions.
Yeah, okay. Cool.
Yeah. Now, there is actually a way we could improve this code using a loop, but we can have a look at that later.
Cool.
Okay, here's some additional examples where we declare different variables. So here we have a user age variable, which stores an integer.
And we have a user height variable, which stores a double.
So a double is a real number, so like 0.5 or
Cool.
10.3
Yep.
or 1.0.
Right.
Yeah, anything If you want a decimal part
a
to
double.
it, then yeah.
And use a student, which is Boolean. What's a Boolean?
So Boolean is a type that allows us to store one of two values, either a true or false value. So you could think of it as true, false, or yes, no, those sort of things. So here we case it, is the user a student? So the answer is true or
Yes.
false, or the
Or
answer
no.
is, you can think of it yes or no is another way to think about it.
Cool.
Okay.
Another example is the smiley face program.
Yeah, so this one calculates the positions of circles, and so we can use some variables and we can calculate whereabouts the circles should be positioned on the screen.
Cool.
Okay, that's it for variables. Variables allow us to store data in our program. Whenever we declare a variable, we are allocating space, so we're creating the variable, we're asking for space. We use the name to refer to that variable. You can put values into the variable using an assignment statement. And you can read the value out of the variable by just using the variable's name in an expression.
So next, why don't you guys have a look at our functions and procedures video or our parameters video.
There's also the looping video after you've watched those to have a look at another way of doing that times table thing a bit more easily. So
Cool.
it could potentially loop forever.
Great.
All right, I hope you enjoy those, and we look forward to seeing
This
you
has
again
been a
soon.
Swinburne production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Cliff, and in this video we'll be looking at adding parameters to procedures.
So far, our programs have been able to have procedures that perform tasks, but they're always sort of a fixed task. The same actions are always performed.
Yeah, wouldn't it be great if we could pass data to the procedures to allow those procedures to have some flexibility?
Well, Cliff, the great thing is we can use parameters to pass data into our procedures.
Oh, cool. I've got this program here, and I quite like it. It draws a smiley face emoji on the screen.
Yep.
And at the moment, it's really cool. I have learned so far that I should be using a procedure for it, so I made a procedure just for it.
Yep.
And as you can see in the code here, like I've called it 2 times, but there's only one smiley appearing on the screen.
Okay, well, I mean, I think the start of our problem is if we look at your draw smiley procedure, we've got a lot of sort of magical numbers there.
Are they good? Do they do magic
no.
for us?
No, they're not good.
Oh,
so they're magic because I have no idea what they mean.
Okay.
Yeah. So what we should probably do is, and if you want to change things, we can't have them literally typed into the code. So these are literal values.
Okay.
Meaning it's always the number 300. If you want the number to change, you could use, of course, a...
Variables.
Yes.
Okay. So, but that still doesn't. I still don't understand why there's only one smiley on the screen though. Like I'm clearly drawing it twice. Where's the other one?
Well, they're both drawn at exactly the same place.
Oh,
so
okay.
there's just one on top of the other.
Okay.
Yeah, so they're both there. You just
All right.
can't see them.
So looking at the draw smiley procedure here, I've got a couple of these numbers that I think I can replace with local variables within the procedure.
Yep. All right.
So something like this, like I know that I'm giving it the center position for the circles because it's basically just a whole bunch of circles drawn over the top of each other.
Okay, all centered at a location
That's
on the
right.
screen.
Yeah. So I've made here the center X and center Y values, so I can try and arrange the pictures around that.
Yep.
But it's still only drawing one smiley.
Yeah, well, because they're always at 300, 300. So this is where we could use parameters. So at the moment, center X and center Y are local variables, so they exist only inside of draw smiley. So when draw smiley starts, it creates those variables.
Okay. Yep.
Which is good because mostly things should be local variables like that. But in this case, what you actually want to do is have main tell draw smiley what the values for center X and center Y should be. So
Okay.
instead of always being 300, 300, main could pass in different values.
Okay.
It's actually really simple to do. What we can do is move these variable declarations here into the brackets at the top of the declaration
Okay.
of the procedure.
So
and so that effectively makes them parameters. Those brackets there are where we place parameters. And they're just variables that have this special property that they're provided a value when the procedure is called.
So are they still considered local variables for the procedure?
Well, they're now parameters.
Okay.
And
Cool.
parameters are local to the procedure,
Yep.
but they're special. They're slightly more special. So a parameter is a local variable, but one that has its value provided in the procedure call. So when we
Okay.
execute the procedure call now, down the bottom here, we also have to change the way we call draw smiley. So draw smiley now says, you must give me 2 pieces of information. You have to
Okay,
give
yeah.
me center X and center Y.
Okay. So yeah, before, even though they were variables, I was still setting it as the one value, but now here using this, I can set each of those variables in the procedure call.
That's correct. Yeah, so where you call draw smiley down here, it passes up now the values, say 150 and 300 would
Yep.
be passed into, so 150 would be assigned to center X,
Yep.
300 would be assigned to center Y.
Okay.
And
So
then that call executes with those parameter values.
does it just do it in the order that we've written it in draw smile?
Yeah, it's the order.
Okay. Okay. Cool.
Other languages have other features, but most languages, it's just purely order-based. Some have name-based, but
Okay.
look, if you deal with this first, later on other languages have
Okay.
different
So I want 2 smileys next to each other.
Yep. So the way we can call that is just to call draw smiley twice and
Yep.
pass in different parameter values. So the second time, the procedure would have different values.
Okay.
And of course, this means that we could draw as many smileys as you want. So we could draw a smiley here, or here, or here, or here,
Okay. Yeah.
etc. So you can draw smileys pretty much anywhere you want to.
Yeah. Okay.
Yeah.
That's awesome. What if I wanted to change the size of the picture?
Okay, well then, this would just be another. What would it be?
Another, you can add parameters for that.
Yeah, well, you can have as many parameters as you want. So let's have a look here. You've got, for example, clear screen. When you call clear screen, it must have a parameter because you're passing in a value for what color you want it to clear.
Okay. Yep.
Where you've got open graphics window, you're passing in 3 values. So those 3 values are going into 3 parameters. And notice they're different types. A
Yeah,
string
yeah.
and 2 integers. Fill circle is taking in a color.
So
So 3 values, this and center X, center Y, and the radius. So you can have as many as you want. Obviously,
so
don't
I've
want
been
to go too
using
crazy.
these all along
Yeah.
and just not really knowing how
Correct.
they worked.
That's right. Well,
I
now
like-
we can actually use it ourselves.
Awesome. So what I could do is add like a size parameter that would be the diameter of the face.
Yep.
Yep. But in the procedure, I've always used the radius to calculate things when I've been doing the math when I've been hand executing it on a piece of paper.
Yep.
Can we have local variables as well as parameters?
Yeah, definitely. So we could add in a third size parameter,
Yep.
and then you could add, say, your radius as a local variable. So the calling procedure, or whatever's calling this code, would only need to provide 3 values, and then you can calculate any number of other values that you want in order to get this to work.
Okay. Cool. Well, here I've got the local variable radius. It's using the size parameter to
Yep.
calculate that value, which is all cool. It's working perfectly for 300. I've gotten rid of a whole lot of these magic numbers here,
Yeah.
which is great. But now when I've sent a smaller size, it's still gone wonky.
That just means your calculations are wrong. So there's no real
Okay.
extra feature here. It's just a matter of sitting down and working out what those magic numbers represent, creating variables for them,
Yep.
and then calculating those values.
Okay.
So I'll let you get to work on that, Cliff.
Okay, well, let me just... Yeah, I've got this picture here that I've been referring to. So,
Yeah.
all right, I think I've got it. So
That was very quick.
Yeah.
Oh, you-
What can I say? I work fast. I've made a bunch of new local variables.
Yep.
So all the things are scaling really, really nicely.
Yep.
And as you can see here, I can...
Yeah, so you've got 3 parameters. You're also able to have a whole bunch of local variables. You can calculate values using the parameters that you've got. You can also calculate other values using local variables or parameters or a combination. And you can pass those into other procedures that you call as well.
0 magic numbers. Looks good.
Well, yeah. Oh, you still got 2, 3, and 6, but
Okay, are they allowable?
I'll accept those. Yeah,
Okay.
that's not too bad.
Okay, cool.
Okay, Cliff, did you want to quickly run us through how this works, maybe just for a couple of the draw smileys?
Yeah, sure thing, Andrew. So we begin at main, and we first open a graphics window and load the default colors and clear the screen to white.
Yep. So each of those are procedure calls.
Yep. Whenever I'm making a swing game program, they're usually the first three things in there.
Yeah.
And then we call draw smiley. So we see here that I'm passing in the parameters 150, 300, and 300.
Yep.
So they're being stored in the center X, center Y, and size parameters. Yep.
Yeah.
And
So this is the bit that we're actually showing off.
that's
here,
right. Yeah. So they're all integers. All of those numbers have been stored in there.
Yeah, and it's just like 3 assignment statements, isn't it? Assign this value to that parameter. Assign this value to that parameter. Assign this value to that parameter.
So long as you get the order and the types correct,
Yeah,
then everything's
it'll all
going to be
be
sweet. Inside the draw smiley procedure, first we've got the local declarations.
Yep. So we've got all those parameters already, and that's why they're a bit special because they got provided with those values
To begin
by the calling procedure.
Yep.
Yeah,
And
and
then
then it goes ahead and creates.
Yep, I've created space for radius, eye offset, eye size, smile scale, and smile offset. They're all integers as well.
Yep.
The procedure begins, and I just do some basic calculations to scale the thing. Based on my original model. So here I've got
So size divided by 2,
Yep. So size was
300.
and so that would make radius 150.
Yep. So we store 150
In radius, that's right, yep. Once again, we read radius, divide that by 3, and store the answer 50 in eye offset.
Yep.
Read radius again. As you can see, this is why I needed a radius. I've used it over and over.
yeah.
Yep, so divide that by 6, store 25 in eye size. Actually, smile scale and eye size end up being the same number, but I made local variables to keep myself sane here.
Yeah.
Just the fact that they're both 25 necessarily mean that would always be the case, depending on the
the way you want
the
to
face that you were
picture to look.
drawing. Yeah.
Yeah. Okay.
Coincidence, I think.
Yep.
Here we've got. I tried to scale it using a decimal number, 7.5, and it wasn't working. And so
So the problem here is when you divide the integer by 7.5, which is a real number.
Yep.
It gives you back a real number, and you can't store that in an integer. So it could be something with a 0.25 or point something attached to it. And so what you have to do is actually convert that into an integer, and there's a number of different ways that you can do that.
So I've calculated that value, and I've stored it in the smile offset.
Yep.
So then leading on to the actual drawing of the picture, we've got a call to fill circle. It takes in yellow. It takes the original parameters that were passed, the center X and center Y, and the radius.
So that's our 150, 300, and then 300.
300 again.
Yeah.
Yep. And so that draws the actual body of the face, the head, I guess. We call draw circle.
Yep.
This time using color black to give
So
it
it's the outline.
That's the outline. Yep.
Same spots.
Once
So-
again, the same parameters that were passed in.
So we read the value from center X, we read the value from center Y, and we read the value from radius,
Yep.
which is your local variable.
Yep. And then we move on to the smile. Now I got pretty clever with this. This is like two circles overlapping. One of them the background color and one of them the foreground color.
Yeah.
Here we've got a fill circle. Once again, we're reading the values of center X, center Y, and I've scaled this smile using radius minus the smile scale. So
Okay.
that should keep it all looking correct again, unlike the wonky one.
Yep.
Fill circle here, this is the one that makes it so it looks like a crescent, I suppose.
Oh, okay, yep.
I was quite pleased with the outcome of that.
Looks cool.
Once again, using center X and center Y with an offset again, so that would be reading 150 and 300, minusing that offset. So that's the thing that just moves that circle slightly up to give that crescent effect.
Yep.
Drawing the eyes here, we've just got two black circles for either side. Yep. So
And you got different offsets for the eye position.
yeah, that's right. Because if you remember in the wonky one, that was the thing that was sort of really noticeable.
Yeah.
But yeah, just having these local variables has solved that problem.
Excellent. And so when this ends, we would go on to draw the other smileys, and so we would get those first two to appear, and we can jump down here maybe to where we call the draw smiley with the slightly smaller one. We'll just step through maybe the first few bits to see, so we can see how those new values are calculated.
Yeah, sure. So in this case, the parameters that we're passing are 150 and 300. So that's the same XY coordinates
Yep.
again.
So same center X, center Y.
That's right. But now 200's going into the size parameter.
Yeah.
So what that'll mean is basically as soon as the procedure begins again, we've got the radius
What's happened to you?
being divided by 2. Previously it was 150. Now obviously 200 divided by 2 is
100.
too good. That's
We
obviously
store 100 in the radius. Yeah.
Yep, that's going to change the rest of them because we're all relying on radius. So now I offset's going to be storing 33.
Yeah, because this is using integer division. One integer divided by another doesn't give you any decimal places, so they're all truncated, effectively, just being chopped off.
Okay, now so it will always go down if
Yes.
if there's a
Yeah,
okay,
just drops.
awesome. I'm sure that will
Anything
be
that's
handy
not
later.
a whole number. Yeah.
Yep. So yeah, I size now is 200 divided by 6, which is 16. Smile scale.
Is radius, so 100 divided by 6. But yeah, 16.
Yep. Thank you. Same again for smile, and smile offset ends up being 13.
Yeah.
Yeah.
And so those values then go into those different drawing functions in order to make the picture appear the way that we want it to appear.
Yeah. So the smiles, the smileys will be in the same place, but they'll just be shrunk
Different.
down.
Yeah, yeah. And the great thing is now we can, of course, draw sort of any number of smileys to the screen of any size. Anywhere, yeah.
Man, that is awesome. You'll have to show me how you did that effect one day.
Okay. Maybe next week. All right, so that's it for smileys, I was about to say. That's it for parameters. Parameters allow you to provide data to your procedures when that procedure is called. So it's a super convenient way of making your procedures much more useful.
Yeah. I really like the flexibility of that.
Yeah, yeah.
What's coming up next?
Well, next we've got functions.
Yep.
So we can have a look at procedures are one way. You call a procedure to perform an action. A function allows you to actually calculate and return a value. We've also got the variables one, but hopefully you've probably already checked that out.
If you haven't seen the variables one, watch that now.
Or watch it before now.
Try and watch it
Come
before
back.
now. Yep.
Yeah, that was good. Otherwise, there's also the next topics material,
Yep.
which is on control flows. So doing things in a loop, like say drawing 1,000 smileys to the screen
Oh, cool.
at
cool.
one time.
Yep.
Yeah.
Oh, sounds like fun.
Yeah. Well, that's it for parameters. I hope you enjoyed it, and we look forward to seeing you again soon. Bye.
This has been a Swinburne production. Swinburne University of Technology.
Hi, and welcome to Swinburne Codecasts. I'm Andrew Kane.
And I'm Ruben, and in this video we're going to be looking at creating your own functions.
So far, we've been able to create programs that use procedures as a list of tasks that sort of perform an action. We have variables that we can store values in. We also should have looked at how to pass values to procedures, so we can create a procedure and we pass values using parameters. And this has given us a range of things that we can actually do where we have a task we want to perform.
Yeah, and procedures have been useful for performing certain tasks for us, like you've said, but I want a way where I can create like a certain artifact that can calculate a value for us, like a meaningful value, and we can use that within our programs.
Yeah, well, this is a case where we can use functions. Functions are a way for us to encapsulate, so capture all of the steps that we need to perform in order to calculate a value. They're very, very similar to procedures, and the code looks very similar, but it has one major difference. A procedure does a task, and so it performs that task, whereas a function should be used to calculate a value.
Okay, well, I think what we've got there, I can perhaps apply that to my little program here. Because I've got all these different mathematical expressions in main, but they don't really belong there. I want to be able to put them, isolate them in their own artifact and every time I call that, it just returns the value that I need it to.
Yeah. So, well, what does the program actually do?
Okay, so this program is a body fat calculator. Okay?
That sounds good.
Yeah, I'm in touch with my weight and just needed something to represent that. So
Yep. All right. So at the moment, I can see you've declared a number of constants.
yeah,
So this is something we should also talk about. So constants are a great way of making values more meaningful and values that are not going to change.
yeah, exactly. And that's why I've got these here, because I need these two values to perform the mathematics required for me to calculate my body fat percentage.
Yeah. So the different constants, you can think about them just like variables, but the main difference is a constant's value doesn't change throughout the execution of the program. So,
Yeah.
for example, in this, we're never going to change the ratio of converting kilograms into pounds.
Yeah, so that's exactly right. Basically, we've got the user, they need to input these values, their weight in kilograms and their waist measurement in centimeters. But the program that I've developed is based on a system that the US Navy came up with to calculate people's body fat percentage. So I need a meaningful way to be able to convert someone's weight in kilograms to pounds and, centimeters to inches. And that's why I've got these constants, and they're more meaningful than just, writing 2.205 anywhere in the code. I want to be able to, see exactly what that value is. So in this instance, it's kilograms to pounds.
Yeah.
And the other one is centimeters to inches, which is 0.394.
Yep, cool. All right, so I can also see down in main, we're reading in the values for the user's weight and waist measurement, and then I'm assuming these next bunch of code here is the code that calculates the body fat percentage.
Yeah, so that's the code that will calculate the body fat percentage, and it'll do it once, but I want to be able to do it over and over again in my program, because I don't want to have to remember this sequence of instructions every time I want to do this.
Yeah, because it's a lot of code you'd have to type in each time.
Yeah.
All right, so what we could do, so does this work for both males and females?
Well, good thing you bring that up. This is just for males. Okay.
Okay.
So that's a good idea. Perhaps I want something to be able to calculate body fat percentage for males and something else that works for females.
Yeah, okay. All right, well, what we could do is move all the calculation code up into our own function.
Okay.
And so that function, we would need to give it parameters. So what the two values the users enter is going to be their total body weight and their waist measurement.
Yeah, yep.
And everything else you can calculate off that. That's right?
That's exactly right. Yeah.
Yeah, so those two things can become our parameters.
Yep.
So that's sort of going back to the video that we've talked about parameters. So this would enable you to pass in those two values into this function.
Yeah. And that's the only information the function will need to calculate that value for us.
That's right. And it can then create its own local variables in order to calculate all of the sort of the values you're using along the way to work out the final result of the function.
Yeah, okay. And this is just like a procedure. I can call this as many times as I want in my program, but the difference is this will calculate a value for me and return it.
Yeah, so what we've got, if you have a look at the code here, we can see the return type.
Yeah.
So this indicates that this function is going to return a double value.
Okay.
Whereas a procedure says that it returns nothing.
Yeah.
It just does stuff and then it finishes.
Yep.
A function performs the steps, so it still does. If you look at it, it looks just like a procedure.
Yeah.
The only difference is that at the end we return a value, and this here determines the type of value, and down the bottom here, this is how we indicate what value we want to actually return from the function.
Okay. And in this instance, the value that it returns is stored in result.
Yeah, that's correct. Yeah, and then the result is returned. And so that is the value that sort of comes back when the function finishes.
Cool. So down here in main now, I've got this variable called fat percentage, or fat percent rather, and I can just assign the value returned by our function male body fat percent to that variable.
Yeah, that's right. So we call this, what happens down here, we call that function, it comes up, executes those instructions, passing those two values across to the two parameters.
Yep.
And then at the end of the function, we get the result, and the result is returned. And so this function called down here effectively gets that value, or becomes that value, and then that value can be assigned into the fat percent. We can print that out.
Yeah, that's really neat.
what's really cool now is you can also just call that function again. And so this time we could pass in some extra values. So say, 74.4 kilos with a 83.4 centimeter waist.
Yeah.
And then that function would calculate the male body fat percentage for that person, and that would be stored into fat percent.
Yeah.
And we can print that out. And so you notice that's much easier than having to type in all of that.
We'll repeat it, yeah.
Yeah. And I think what you'll find even cooler, notice we're only really using the fat percent just to output the value.
Yeah.
What we could actually do, rather than storing the value in the variable and then using the variable, you can just use the result of the function inside another expression. So down here where we're printing out the value, we can just call the function, and whatever value is returned, we can just say, we'll just print that out. We multiply it by 100, etc.
Yeah.
And then print that value out. So you don't have to always store the values in variables if you don't need the variable for some other use.
So what you're saying is that will do the same thing as assigning that value to a variable and then printing that variable out.
Yeah. The only thing is at the end of this line here, you can't get back to that value.
Yeah.
You used it and it's gone.
Yep.
Whereas if I stored it in a variable, I could then just use the variable over and over again.
Cool.
So you have to think about that. If you only want to use it once, then you don't need to store it in a variable. Just use it wherever you want to use it. Otherwise, store it in a variable and then use it multiple times.
Yeah.
So one thing you'd want to avoid would be, say, if I wanted to, use the male body fat percent of the person with 82 kilograms, 101.4 centimeter waist, then if I call that function again, it has to go back up here and recalculate the value. So if I did want to use it more than once, definitely save it in a variable.
Yep.
Only using it once, you can skip that step.
Cool.
All right, Ruben, did you want to run through how this works? Maybe we'll just go through the first calculation of the body fat percent in detail, and then the other ones will just sort of... The steps are the same, but we'll just skip over them a bit more quickly.
Sure. So the first thing that happens when the program is executed is we go down to main, and we've got these variable declarations here. The first two are weight and waist measurement, and they're doubles. And fat percent, which is also a double.
Yeah, so we've allocated space for 3 variables, all that can store real numbers.
Yeah.
Yeah.
Yeah. So the first thing that happens in the program is we assign a value to our weight variable, and we do that by calling read double.
So what do you think read double is?
Well, now that you've told me about functions, I'm almost certain that read double is in fact a function.
That's correct. So read double is just a function that somebody else has written.
Yeah.
In this case, us. And that function takes in one parameter, which is the prompt, the message we're going to show the user. It then reads whatever I type at the keyboard, and that value, when it comes back, is assigned to that variable.
Yeah.
So that we've been using functions already. This is just now we can also create our own.
Yeah, cool. So in this instance, let's assign the value 90.2 to our weight variable.
Yep. So 90.2 comes back from the function.
Yep.
We store it in the weight.
Yep. Now, our next instruction is to assign a value to our waist measurement variable. So the same thing happens again.
So it's using the read double function.
Yep.
Let's assume the user types in 86.5.
That'll be good. And that value is then returned by that function and stored in the waist measurement variable.
Yep, by the assignment statement.
Yep.
So now we get up to our magical part. Yeah.
This is it. So this is where we get to use the function that we've created. We're going to call male body fat percent, and we're going to pass those two values in from our variables weight and waist measurement as parameters.
Yeah. So weight will be passed up, and it will go into the total body weight parameter in the male body fat percent function.
Mm-hmm. And then waist measurement will also be passed up into the waist parameter in the male body fat percent function.
Yeah.
Okay.
Cool.
So that function's been called. We've got some variables here that are declared.
So it's going to appear on top on the stack. So
Yes.
that when this finishes, it knows where to go back to.
Yeah, that's correct.
Yep.
We've got these different variables here: factor 1, factor 2, lean body mass, body fat, weight, and weight in pounds.
Yep.
We need all those different variables for our calculations.
Yep. So they're all allocated space.
Yep. Okay, so the first thing that we need to do is we're going to calculate total body weight multiplied by our constant value of kilograms to pounds.
Yeah, so this is going. So this, when we use the constant, it's just like using a variable that's actually just going to be replaced with the value 2.205.
Yeah.
And so effectively, what you're doing here is converting the user's weight in kilograms into pounds.
Yep.
So you can use that through the rest of the code there.
Yeah. And that expression is 90.2 multiplied by 2.205, which is equal to 198.891.
Cool. And that gets stored in our weight in pounds.
Yeah.
Cool.
Our next expression is we've got weight in pounds, so the value that we just calculated. We've got to multiply that by 1.082 plus 94.42.
So the result of that, 309.62,
Sounds pretty
which is stored in factor 1.
Yeah.
Now, in this case here, we do have two magic numbers, 1.082 and 94.42. These just come from the
that system.
US Navy's
Yeah.
formula. They don't get any reasoning or rationale, so
Yeah.
we can't really come up with meaningful names for those values. So you'd have to think about whether we could come up with something, but in this case, we'll just leave them as values.
Yeah. So that value gets assigned to factor 1.
So we calculate factor 2, same sort of way. So waste times this kind, we're converting it centimeters to inches.
Yeah.
And they've got their magical factor of, well, it is magical, isn't it? We have no bloody idea why it's 4.15, but that's what it is.
Yeah.
So we multiply that by 4.15. So that gives us a total of
141.436.
Yep, which we store in factor 2.
Yeah.
So when we calculate the lean body mass, that ends up being
168.184.
Yep.
Yep.
And that gives us a total body fat of, what is that, 198.891 minus
168.184,
So-
which is 30.707.
Yeah, and that is stored in our body fat.
Yep. And now we're up to our body fat percentage result calculation,
Yep.
which
So-
is body fat weight divided by weight in pounds.
So 30.707 divided by 198.891.
Yep.
Which
Which
is-
is 0.1544.
Yeah, and that is stored in the
Result variable.
Yeah. So at the end of the function, what happens?
The function returns that value. It returns our result.
Yeah, so it returns the result.
Yep.
Which is 0.144. So what happens now?
0.1544.
Yeah, thank you.
That's okay.
So we come back down here to main now, and this function call here has now become the value 0.1544.
Yep.
So that's what we mean by return. We mean that the function ends, and where it was called from becomes that value.
Okay.
And so this is now 0.1544, and so we can then just store that.
In our fat percent variable.
Yeah, so when we print it out, we get 15.44%.
Yeah.
Yeah, seems quite reasonable.
It does. That's a healthy individual.
So we then call the function again, and this time, those two, we just get literal values passed across. So
Yeah.
74.4 gets passed into total body weight, and 83.4 gets passed into waste.
Yeah.
And we then go through those same steps.
Yep.
And it calculates, so we calculate the weight in pounds, factor 1, factor 2, etc.
Yeah.
And at the end, we get our result, which is,
In this case, it's 0.1737
yeah, and that gets stored.
into fat percent.
Yeah, so that's the result that's returned.
Yep.
Becomes that value, and we store that in that fat percent.
Yeah.
We can print that out. And the same thing happens down in the bottom here. So when we call the male body fat percent with 82 and 101.4,
Yeah.
that function gets executed. It runs all of the steps. At the end, it returns the value, and then it's just like you typed 0.3128.
Yeah.
Yeah. So that value there, 31.28%, when we multiplied by 100, that is,
Yeah.
would be printed out.
Cool. And that pretty much wraps up the execution of that program.
Yeah. So here are some other examples.
As I said before, we needed another function to calculate female body fat percent because that one that we just demonstrated was for males only.
And so this is that function. Takes in a few extra parameters, has a few extra steps, but the same sort of idea. You
Yeah.
call the function, pass in the values, it does its magic.
Yep.
Yeah, it comes back with a result.
Yeah.
We've got another one here to calculate the area of a circle. So we're using another constant here. So we create a constant for pi.
Yeah.
And we would have pi multiplied by the radius. It's a lot simpler function.
Yeah.
But would make it easier if you had to calculate circle areas
Yeah.
a number of times.
And the final example here is squaring a number. And basically, you pass it a number as a parameter, and it will square that number for you and return a result. So, if you passed in 2, it would return 4.
Yeah, and so these other ones are slightly simpler functions. All right, that's it for functions. Functions, just like procedures, but they're used to calculate a value. So this is really useful if you have a bunch of steps or some sort of calculation you need to perform and you want to get a result back, like a number. It doesn't have to be a number. It could be, we did doubles in this one. It could be returning a string, such as read string.
Yeah.
Or integer, read integer, etc.
Yep. We've also got some videos on parameters and procedures, as well as variables.
Yeah, so if you haven't checked those ones out, go back and have a look at those ones now. They should sort of complement this one.
Yeah, and coming up, we're going to be introducing you to control flow, which gives you the ability to introduce much more dynamic behavior in your programs.
Yep. All right, that's it for functions. Hope you've enjoyed this, and we look forward to seeing you again soon.
Bye.
This has been a Swinburne production. Swinburne University of Technology.
Hi, welcome to this podcast on hand execution. So what we're going to have a look at in this podcast is first, well, what is hand execution? And then uses of hand execution. So why am I asking you to do this? And performing hand execution. So the process by which I want you to be able to perform hand execution as part of the unit. And it's important that you follow the process that we've specified. So what is hand execution? When we're programming, we write code for the computer to execute. With hand execution, what we actually do is execute that code ourselves using paper and pencil. It's a fairly simple process, but it's really important to help us understand what the code we are writing does. So as I said, we write code mostly for the computer to execute. That's the purpose of our code. But what we want to do is really understand what that code does. What does that code tell the computer to do? When we understand how the different statements get the computer to do different things, you can then better understand your code, and you'll be able to create code that will do whatever you want to do because you'll understand what each of the different actions gets the computer to do. So with hand execution, what we're doing is performing the actions that we have in our code one step after the other. Now, the great thing is computers are unintelligent. So hand execution isn't super tricky. It's doing what a computer does. A mechanical process do exactly what the code says to do. And so the one thing you have to really understand is what are the actions that the code means. So when I say x colon equals 10, what does that do? What does that mean? So we have to understand how the computer interprets those, or how the compiler gets the computer to do those actions. What is it actually doing? You then perform the action one after the other. So each action you just perform in sequence, the same as the computer would do. And the key here is to understand, what are these actions getting the computer to do? So when we write a certain piece of code, what does the computer actually do when it runs that piece of code? And that's what we're really after here, that understanding. Now, when we go through hand execution, some of the things you might want to do as you're going through it, it is a mechanical process to execute the code, but then we can try to understand the code more deeply. What was the purpose of this code? This code was written by a programmer. They had some purpose. They wrote it for some reason. hopefully. So they wrote the code for some. What does it do? Why are these set of instructions provided? What does this sequence mean? What does it do? And we can analyze the code that we're reading to try to work out how it achieves goals. So if I know what the task is, it's supposed to be doing this, but I don't understand how it's doing that, then when I read through the code and try to execute, work out what it's doing, I'm analyzing that code in order to work out how it achieves the goals. So I know what the goal is. How do we actually achieve that with this piece of code? So in general, the uses for hand execution are, well, firstly, to help you understand what are we telling the computer to do. When I say this piece of code, what does it mean? What does it get the computer to do? It also gives us a way, or gives you a way, to demonstrate that you do understand what the computer does. Because part of the assessment for this unit is you need to demonstrate your understanding of these different actions that you're going to get the computer to do, the different statements in the programming languages. And so by hand executing something, you're able to show, I can read this code and I can tell you what the computer will do. Okay? So it's important with this hand execution process, you're trying to demonstrate the process, not just the final answer. All right, we don't want an answer out of this. This is a process demonstration. Okay. Another thing that we can do with hand execution is locate errors. Sometimes, quite frequently, I think, the code that we write has small mistakes in it, obviously unintentional, and we write it thinking that it's going to do what we want it to do. But when we run it, the computer doesn't do what we want. It's very frustrating. But what we need to do then is look at our code. The computer's done exactly what we told it to do. Yeah, so the problem, it's our problem. We made a mistake. We need to think about, well, what does the code actually do? And so hand executing gives you a way of going through the code and saying, well, I know I wanted it to do this, but it's doing something else. Why is it doing that something else? And you can look at your code and work out where your errors are. Okay, so now let's get to the process of hand execution. Okay, so here what we have is some code. And that code is the code to draw a house. And it's taking some parameters. We've got some local variables here. And we've got some actions. And what we want to do is work out what these actions do. What happens when we execute this code on the computer. Now down the bottom here, I have my call. So we're going to execute the call to draw house, which takes parameters or takes values 50, 75, 100, and 200. So what happens when this code is executed for that procedure call? So over here, what I could do is, let's just write down that procedure call so we don't forget. So it's draw house. Sorry about my writing. 50, 75, 100, 200. Okay, so that's our procedure call. Okay, you have to bear with my drawing. So what we want to do now is execute this code. So this call has happened, and the computer is now going to execute this procedure. Now, if we look at that, oh, that's a lot of code. How are we going to understand all of that? Well, remember, the computer doesn't do that. It's not looking at all of this and trying to work out some greater meaning for what draw house means. It's just going to execute this. So let me just hide away all the stuff we don't want to see. Okay. When we're doing this, just focus one line at a time, okay? And sometimes less than a line. But at the moment, one line at a time. So here's our one line, draw house, X, Y, width, height. That is the piece of code that we're starting here. This is going to execute this draw house procedure. And we have these parameters here. Now, parameters are variables. So this piece of paper here, or this drawing here, you should do this on a piece of paper with a pencil. Yeah, no need to make it fancier than it needs to be. What we can do is this can represent memory. And inside this memory, we can allocate data for our variables. So X, Y, width, and height become variables. So I can declare a variable X, and it's allocated a piece of memory, which I'll draw a box to represent that piece of memory. So here is X's memory, that bit there. Whenever I refer to X, I mean whatever is written in that box. We can do the same with Y. and with width and height. There we go. Excellent. So when we execute this, the first thing that's going to happen is the computer needs to allocate space for all of the parameters. So each of these parameters becomes a variable inside which we can store a value. And these values here, the 50, 75, 100, 200, are assigned to these variables when this procedure starts. So the value of x will be 50. The value of y will be 75. The value of width will be 100. The value of height will be 200. Okay, so there's our parameters. Let's switch back to our code. So we've finished executing that line of code. Let's move down. All right. Oh, we can look at these ones all together. The next thing that we have in our code is var. So this is a variable declaration section. And in here, we have a number of different kinds of variables. So we can have roof height, and we create a variable for that. There it is. We need wall width. We create a space for that. We can have wall X. Wall Y. Right side, maybe up here. And middle. Okay, so this has, when this code executes, the computer allocates space for a number of different variables. Now, at this point, what we'll do is leave these variables empty because we don't know what their value is. If you ask me what is the roof height, well, I don't know. It's something, but we haven't yet given it a value. There will be a value here in the computer, but it's we can consider it to be a random value because we haven't given it a value. It's just whatever happened to be in memory the last time this bit of memory was used. Okay? So it's important that you assign a value to your variables before you use them. All right, so let's move on. What's next? Now we have our begin. All right, we're getting a bit. We do just want to focus on one line of code, so you can also forget all of that. There we go. Look at that. Just one line of code. Begin. All right, that just means start. So we can start. There's the next one. All right. So what we have now is a statement. What does this statement do? So this is an assignment statement, and we know that because of this colon equals symbol here. So an assignment statement does two things. So it gets the computer to do two things. The first thing the computer does is evaluate the expression on the right-hand side. So that's this expression here. And whatever the result of that expression is assigned into this variable, the roof height in this case. All right, so let's evaluate the expression. My expression is round, open brackets, 0.33 multiplied by height, close bracket. Okay, what does that mean? Well, round is a function, and this function takes a floating point value, like a single or a double value, and it returns a whole number, an integer. Okay, and it's going to round that off. So 9.9 would round to 10, whereas 6.2 would round down, so it would round to 6. So it rounds up above 0.5, etc. All right, so what's my calculation do? 0.33 multiplied by height. Well, what is height? So we don't need to remember that. We just look over here. It tells us height is 200. So 0.33 times 200 will be 66. And it'll be 66.0. because this is a single, a floating point value. But what we'll do is round that, so it will become 66. And so the value here is 66. And that is assigned to roof height. So roof height is assigned the value 66. Okay. That's that statement done. We can move down to the next statement. All right, so the next statement, similar thing. 0.8 multiplied by width is going to be rounded and assigned to the wall width. So remember, it's an assignment statement. So first thing, evaluate the right-hand side. To call the round function, I need to work out its parameter value. So this value here has to be calculated first. That will then be passed into the round function. It will round it off for us, and the result that we'll get will be the integer value. So 0.8 times width will be 80, 80.0 in this case, and that 80.0 will be rounded to 80, and we can assign 80 to the wall width. So wall width over here becomes 80. All right, that's that one done. And notice this is all we do with hand execution. Usually you don't have these boxes to help you, but just focus on one line at a time. Assignment statement, height minus roof height. All right, so what's height? Well, height is 200. What is roof height? Roof height is 66. So what is 200 minus 66? All right, and we assign that. So 200 minus 66 is 134. 134 we are going to put into wall height. Did I miss that one when I wrote it down? I did, didn't I? Okay, that's okay. We can adjust. In my rush to get through this, I forgot to create the wall height variable. So let's just add that in quickly. Nobody will know. Wall height. And 134. Okay, so there's our wall height. And we can continue on to execute this. We can continue to execute each of the assignment statements one after the other until we get to the end. So that's the hand execution complete, and what we can work out from this is the shape of the house. So each of the different variables represents different values related to that house. So if we go through that, we can work out that the house shape should be something like this, based on the different values, the wall X being the offset from the edge of the triangle for the wall, the width and the height of the rectangle being the wall width and the wall height, and then we have the roof height as well. Okay, so that's the process of hand execution. I hope you enjoyed it or found it useful, and I'll talk to you later. Bye.
This has been a Swinburne production.